talk and let's start. Welcome back, second day of CiscoLive, and welcome to Breakout 2458, Nexus Operations and Maintenance Best Practice. So before we start, I'm Arvind Durai. I'm a US principal architect taking care of the US enterprise customers. I worked on several designs in architecture design, but one of the key things that makes me quite relevant to this presentation is I worked with several customers optimizing the operation windows, resiliency in the environment. So that's one of the key things that we will be going through in this particular presentation. I also have two Cisco Press books, one on firewall service module and the other one is on Tickle, and two CCIs. With that, I'd like to, Nick, would you introduce? Yes.
Good morning, everyone. My name is Nick Garner. I've been with Cisco since the end of 2007. I've been with Advanced Services throughout the last 8 years doing consulting for enterprise customers, primarily based in San Jose. Focus on campus and data center in my day-to-day job. Prior to Cisco, I worked for a large bank that is no longer a bank after 2008. And before that, I was in, who's Marine here? Any? Yeah, there they are. They're all camped out over there. What's wrong? Let's see. I do a lot with ACI these days, supporting the largest ACI environment in the world. We're not going to be touching on ACI in this presentation, but feel free to come up afterwards if you have any particular questions. I have two CCIEs, and I'm pretty excited to have everyone here. We're going to be talking about some new features in XOS 7.2, so let's get started.
Thank you, Nick. And with this, I'd also like to introduce Satish and Arkady. Can you please stand up for the crowd? All right. So these guys have worked with us not only in the presentation, but also to get some cool features that's helpful for us in change windows. And they have a big team behind them supporting all these new features. These features that we're going to go through in this presentation is going to be an evolution of the next-gen features that's going to support us in maintenance windows. So I'm quite excited out here.
If I could add one thing to that. So these gentlemen are also our question managers. So if for some reason you don't want to stand up and ask us a question, feel free to use that tool that's available to everyone in here. They'll be monitoring that and can answer quickly.
And these guys are the top guys knowing all the innovation stuff which is happening for this particular feature. Let's go through the agenda. My point of view is, so the agenda out here is VPC refresher. That's what we're going to go through first. Operational best practices in software and hardware, ISSU, some of the hardware best practices. How do we isolate a node? And the next one is GIR, graceful insertion and removal. This is a cool feature available in 722 code, and that's something that we are going to go through in this particular presentation. We're going to go through the details of this particular feature and how we could leverage this feature in our change windows. And finally, to wrap it up, we will be going to change window best practices, the methodologies that we normally follow during the change window, and how we customize this methodology from advanced services for our customers. The objective of this course, this next 2 hours, is operational best practice. That's number one. The next one is to have a proper understanding on GIR feature. And the third one is change window best practices. These are the 3 outcomes. We're going to go through several presentations out here in CiscoLive. And if these 3 outcomes are something that you get out of this presentation, Nick and I would feel that we guys have been successful in our presentation. High-level overview of technology. And more than technology, it is what is a deployment roadmap that we have seen with customers. Prior to 2008, we always talking about blocking in the data center environment, and that was spanning tree. And then around 2008 to 2009, there was a slow transition which took place, and we started talking about everything is forwarding, constrained spanning tree in a VPC environment, right? And then in 2010, the top-of-the-rack switch design changed using FEX with VPC. There was a huge deployment that was happening all around our customer base. During 2010 itself, what happened is there was a requirement to scale, east to west scale. With the east to west scale, we wanted a separate control plane, right? So that's when Fabric Path got introduced to provide us the east to west scale using the control plane using ISIS. And then came the standalone VXLAN environment. VXLAN has multiple modes of deployment. The earlier mode of deployment was mostly on the flood basis of VXLAN using multicast. And now, right now, when I'm working with a couple of customers in the designs, we are using EVPN using BGP to have a much optimized control plane for VXLAN. Now, what does VXLAN really get from Fabric Path is, how many of you guys are familiar with the number 4096? Raise your hands, please. Yes. That's the scale limitation of VLAN. If I want to scale more than 4096, VXLAN provides us 16 million entries that we could leverage in a broadcast domain. So that's something that a VXLAN really got us. Then 2014 to 15, there's a lot of deployments that we are working on the ACI basis from Cisco Advanced Services. Now, when ACI completely changes the way in which we look at the fabric, it's no more a standalone fabric. We have the fabric as one single entity, and it's infused from an application. So the transport is infused from the application area. As you could see, in this particular presentation, you see the blue box, and that's going to be the area of focus. Now, VPC is key. Whether you go with a VPC domain environment, what you learned in the VPC domain environment, or you go with Fabric Path, or you go with VXLAN, VPC is still relevant. Because in these diagrams, if you see in the Fabric Path, you see VPC is there on the leaf side, or in the VXLAN on the leaf side to provide redundancy on the leaf basis. So with that said, VPC is very important for us. Let's go to a 2-slide refresher on VPC. Important to understand, especially what happens when there's a failure that takes place. S1 and S2 switches are bound together in a VPC domain. They are the pure switches, where S1 in this case is a primary and S2 is a secondary. Let's take this, bound by a pure link that exchanges Cisco Fabric messages, and then multi-ether channel is being bundled to the S3. So S3 has two forwarding paths towards S1 and S2, taking as one particular system. You have the VPC Keep Alive link, important for HA and redundancy for the VPC peers, and the member ports. The other concept out here is orphan ports. Orphan ports, if it's single connected to a particular, orphan ports, if it's single connected to a particular VPC peer, it is okay. Sometimes it's a capability that the platform offers. But when you're working on a change window, if it is single connected, that means you cannot make it more graceful, because there's going to be a service disruption because you have host assets that's directly connected to it. So that's something you need to take into consideration. Moving forward in 722 code, which is going to be out in the next 2-week period, we have a capability of having dual connection from FEX on a 7K. So that is great. Now, why is all these things important? What happens during a failure scenario? During a failure scenario, if both become active, what happens is the S2, the secondary, will shut down all or disable all its ports. And then when it disables all its ports, your in-flight packets will have an impact. So the packets that's going to S2 will get dropped. In a change window, when we plan a change window, the way we optimize the in-flight packets is something that we need to take into consideration using best practices. A good change window and a more disruptive change window depends on how these in-flight packets are managed. And that's one of the reasons we need to have best practices in our environment. Now, best practices are very simple. Have a unique domain ID for VPC. Make sure that is constant in your whole topology. Pure link should have dedicated connections and point-to-point. VPC keep alive links, if you have a dual supervisor environment, make sure from a VPC keep alive link you are using a switch to take care of false positives. There's some chairs out here, so you can move out here. VPC peer gateway. Sometimes when you have your packet having a router MAC address, then what will happen is you tend to use your peer links always. To avoid and optimize your peer links, use peer gateway command. And then comes VPC peer switch. Peer switch is really cool. I've used, like 2 weeks back, I was looking, one of the AS engineers came and asked me, Arvind, I want to customize and optimize a change window. How do I do it? We were getting in the lab 90 seconds, and they were running a 6.x code, it's an older code. Using some of these best practices and cool features, we got 22 seconds disruption in the change window. Again, each environment is different, right? In real deployment scenario, so by just using the VPC switch, we got a tremendous improvement in the disruption type. So one of the key things is, what does VPC peer switch offer is, it optimizes the environment, optimizes the BPDUs. It takes the whole VPC S1 and S2 as one logical switch entity. The next thing is hardware best practices. Use distributed port channels for your VPC members, and also oversubscription. And oversubscription is something that we really need to understand. Every time I get into a change window planning with the customer, we understand what is, how oversubscribed are your links. Because if your links are heavily oversubscribed, then you're going to lose more in-flight packets. It is not going to be graceful. What does really graceful mean? Graceful is how your applications would react when you bring down any part of your system. And with the least disruption, it becomes more graceful. Oversubscription, most of the designs, traditional VPC designs, is from north to south, or south to north. That's how the traffic type is. If you suddenly see oversubscription increasing, that means you need to understand where your traffic is going. Is it going from east to west, or west to east, and north to south? And that's one of the reasons in the design phase we start looking into traditional model of VPC, and also we start looking into spine and leaf type of models. So oversubscription is important. You need to understand how much your links are oversubscribed, and that's one of the best practice. Quick wins, easy to implement. One of the things, if you don't have it implemented, go and implement this. It's simple, easy, and has a high impact in terms of resiliency of the whole system for planned and unplanned changes. Let's go through auto recovery feature. This is also another cool feature that I find it very near and dear for operations. In this particular example, the pure link is down. Immediately we know that S2 is going to disable all its ports and S1 is going to be active. And now you have a, sorry. So the question is, to repeat it, the question is pure gateway and pure switch. Does it require maintenance window? No. However, when we add anything in the environment, and that goes into the planning stage, we need to take risk factors, any type of unknown issues into consideration. So you're not going to have any impact theoretically, but once I get through the methodology of planning a change windows, we can go through that. That's a good question. So auto recovery. So as the pure link fails, S2 disables, S1 comes active, and then you suddenly see a second failure that's taking place. S1 is going down. The pure keep alive link is also down. So what happens in traditional way is S2 waits for some time and then takes the role. This takes time. At least twice or thrice in proof of concept lab when I was working, I've gone and monkeyed around in this particular state. Why is S2 not coming up? And I'll just reboot the box. How many of us have done it? Right? So Auto recovery is something that we could leverage, because what happens is if it determines this particular state, it will bring the box up automatically and S2 becomes operational primary. It's a good feature to use. Self-isolation. Another cool features, which is a set of features, but self-isolation is the starting, which is introduced in the 7.2 code in the 5K, 6K, and the 7K family. What does this feature do is it does an automatic triggered isolation. In this particular example, if you have all the line cards that's failed in the primary, automatically the traffic gets moved to S2. There's a persistive state that's maintained in S2. There are two use cases that isolation really works, and when I saw this feature in an engineering code release in the BU labs, the recovery was awesome. In fact, it was like, you would get a millisecond recovery from north to south, east to west type of traffic. So one use case for VPC self-isolation is you have to enable this feature. 7.2 code, if you go to 7.2 code, you have this feature enabled, and one of the things you could do is just enable this feature, and it will help you for fast recovery on planned or unplanned changes. The next use case for isolation is if you suddenly have no VLANs in your peer link. It could be something due to a hardware programming or some manual intervention error that you have seen. What happens is automatically the trigger will be, it will move all the traffic to the S2 switch, and S2 becomes operational primary. So kind of like the convergence and the resiliency improves in milliseconds using this particular feature. So if you guys go to the 7.2 code, which is going to be released in the next 2 weeks, please use this feature in your mind and enable this feature with auto recovery in your environment. Object tracking. We all have used object tracking in iOS. How many of us have object tracking enabled in a VPC environment? Great. There are only a few hands out here. But where I have used object tracking, if you have 1 or 2 links that's in your northbound connection that fails, maybe one link fails. From your routing protocol, everything looks good, right? It's northbound connection. Some type of application slowness is observed in this case. For example, multicast. Multicast, even though you have 2 VPC peer, it will only maximum take the first VPC peer, which is operationally primary. So in this case, if you start seeing application slowness, you get a request, you start looking around and say, oops, one of the interfaces is down, or you look at your syslog alarms, you see that one of the interfaces is down, you go ahead and then change to the other side. You move the traffic to the other side. With object tracking, you can get this completely isolated. And with isolation feature also, you can get a better resiliency with object tracking, which is tracked with the VPC command. A quick high-level overview of stateful switchover. We all are familiar with stateful switchover. Stateful switchover works for all layer 2 based protocols. You have dual supervisors, active standby, the state is maintained, and you have checkpoint facility that maintains the state on a regular basis. And then you have SSO compliant applications like the routing protocol applications that is SSO compliant. I get a lot of questions even internally within Cisco. Arvind, should I go ahead with NSF or NSR? So thought of putting these 2 slides gives a high-level overview of NSF, and then we'll compare it with NSR. In this particular slide, as you see, the routing protocol is available in the active engine, soup engine. And your standby does not have routing protocol active. But your fib table is synced between your active and standby. So that means if you have a failure in your active, your state is completely still preserved and your data path is still preserved through this standby. Then what happens is a capability exchange takes place. This capability exchange takes place, and then the standby supervisor adds all the RIB entries onto it. In NSR, it's very simple, as it shows out here. In NSR, both the active and the standby have these entries together, right? The RP and the FIB table entries are maintained in the active and standby. Now what happens is, if the active fails, there's no impact. And there's no impact to the traffic, same to NSF. And from a routing protocol basis also, there is no rebuild of table that takes place because the state maintenance is there. It's stateful. So in Nexus world, the NSF is equivalent to graceful restart. And NSR is equal to stateful restart. I don't know. So when Nick goes through his presentation of Nexus OS, you will understand he will be using the word graceful restart and stateful restart. You should have this high-level picture in your mind of what is the difference between graceful restart and stateful restart. When you're deciding which type of routing protocols you have, because it's important that protocols matter, right? So when you're thinking about a graceful environment, you need to understand what NSF supports, what NSR supports, and plan your environment accordingly. You might have, so that's something that is very important for you to consider. Now, with all these best practices, if you have these best practices deployed in your environment, for an unplanned or a planned outage, you really don't have to worry about convergence and resiliency. It's sub-second convergence you would get. And this is based on lab testing. Link failure, node failure, if you do NSF SSO on a supervisor, it is below a second. How many of you folks have OSPF, BFD, or for routing protocol, BFD and SPF throttling timers enabled? Raise your hands, please. I see a few. That's great. Because if you have this enabled, the convergence factor is going to change dramatically. Without these values, your convergence for OSPF is about 5 seconds. With these things added in, you could get below a second. Now, this is something that in 2010, I was working on a inter-DCI data center design for a financial customer. And we had to get resilient DCI recovery between Virginia and Singapore. We got around 220 millisecond convergence. Again, depends on the environment. And it was different. 2007, different technology, different platforms. But one of the cool things that these timers provided me from a design perspective, working with the ops to understand the application resiliency, is we were able to get 210 or 220 millisecond convergence. So if you don't have it, think about this particular timers. It is good to have it for your northbound and southbound traffic in your environment. The next 3 slides, we're going to go to a very 1,000-foot high-level case study. And this case study will align with how best practices apply to different environments. This is a traditional VPC environment. And from an operations perspective, normally what we would think, and how do I do a core node failure or a link node failure? How do we isolate those nodes? How do you do an access node failure? Those are the key things. When we are planning those things, the best practices that align with it, and these are block best practices. So think, when you're going into an environment, think how these best practices align with my environment. The routing protocol best practice in this case will be applied only to your core, because that's where your L2, L3 boundary is. Your VPC best practices will get aligned to the core. In a lot of instances, if you have a double-sided VPC, you're going to have it also applied to the access. And then you have hardware best practices that we talked about applied to the whole system. Next environments, again, this is pardon the spell mistakes, spine leaf environment. Again, when you're looking at a spine leaf environment, you look at how do I bring my spine down or isolate my spine. You're going to hear this word isolate a lot in this particular presentation. How do I isolate my leaf? Now, in this particular environment, it's layer 3, and some large data centers use layer 3 using eBGP between the spine and the leaf. When you're using BGP between the spine and the leaf, then you run into routing protocol best practices that apply not only to the core, but also to the leaf. You have hardware best practices that applies to the whole system. And then VPC is still relevant, because if you want to give HA to your leaf, you need to go with the VPC best practices that applies out here. The next one is layer 2 spine leaf. So we have multiple ways of doing this. Use fabric path, control plane is separate, or use VXLAN. VXLAN deployments around a year before used to be mostly in the flood way, using the flood method. And now moving forward, VXLAN deployment has leverages EVPN using BGP. You can use iBGP or you can use eBGP in this. So even when you have different technologies, different types, from operations perspective, the only thing that hits our head is how do I isolate a spine? How do I isolate a leaf in this environment? And then based on the technology, how does my best practices align to it? You have hardware best practices that aligns to the whole system. Routing best practices, because you're running BGP, ISIS, or IGP. Your underlay and your overlay control plane has to depend on routing protocol best practice. And the VPC best practice is still very much applicable to the leaf. So what we went through out here is best practices and use cases. After Nick goes through the bells and whistles, the new features within software and hardware best practice, graceful GIR feature, what we will do is we'll use the same slides to summarize how do we apply these features in this use case environment. All right? Nick?
Good morning. Good morning. Hey, is today anybody's birthday? Somebody. It's got to be. There's 700 of you in here. All right, we were going to sing you happy birthday, but... All right, so in the last 3 slides, Arvind talked about where we apply a best practice, or which best practice we apply where, right? So in these next 4 sections, whether it's software, hardware, isolation, or graceful insertion and removal, I'm going to talk about best practices. Starting with software. Before I get into software, though, I want to talk about 2 key concepts of NXOS. First one being process modularity. Back when they created NXOS back in 2007, 2008, this was one of their key requirements. They wanted the ability to have a process not affect another process. So OSPF crashing should not affect EIGRP, for example. So gone are the days of monolithic iOS and you crash OSPF and the entire system is going to reload, right? So we have these 3 key tenets of process modularity. Stateful restart, which is where we have a lightweight database, that's the persistent storage service, which will checkpoint the state of a process so that we can restart that process, get our previous state, and come up and running. So think of nonstop routing when you think about service restartability, or rather stateful restart. Next up, graceful restart, which is the equivalent to nonstop forwarding, which Arvind talked about. And this is where we can query our neighbors to get our state. So OSPF goes down, comes back up, ask our neighbors, or tell our neighbors that we're coming back up, we need our previous state information so we can start, participating. And then we have stateless restart, the final option, which is where we restart a process. We have no known information, we just, bring up our states as we normally would with that particular protocol. Process modularity is going to be very important in about 8 slides. So keep this in mind, because we can't accomplish what we're going to be talking in a few slides unless we have process modularity. Let's look at an example of what occurs during stateful fault recovery. So in this example, OSPF has crashed, and the high availability manager needs to make a decision about what it's going to do. In this case, it's going to decide to restart the process and do a, I think I just hit someone in the eye with the laser pointer, sorry about that. And do a graceful restart. Now, there's something interesting that we can tell about what happened with OSPF here just by the fact that it did graceful restart. By default, the high availability manager, upon first crash of the OSPF process, is going to do a stateful restart, meaning it's going to use the state that's stored in the persistent storage service to restart that. And that's entirely local to the switch. There is no notification to neighbors. It is, let's restart, we have our old state, and run. Something we can tell from this is that OSPF has crashed in the last 4 minutes because graceful restart has occurred here. If stateful switchover occurred, you see that as an option there. The HA manager can say, I'm going to do SSO. If stateful switchover had occurred, then OSPF had crashed 3 times within 4 minutes. So we can tell just by the way the protocol acts what or how the HA manager is making decisions. Excuse me, whoa. Our routing updates come in. During, I don't need to talk about opaque LSAs, but so let's talk about stateful switchover. Arvind touched on this. I need to touch on it again because it's pretty important for software, particularly in-service software upgrade. So stateful switchover allows you to have 2 supervisors up and running. State is synchronized between the 2 constantly so that one can go down, the other one can come up. It's standby hot, comes up, starts participating in the control plane, and forwarding doesn't get impacted. For routing protocols, we have that stateful restart. We also have the graceful restart where we can, I just touched on it in the previous slide, so I won't touch on it again. We have 3 triggers for stateful switchover. HA policy can initiate it, so I touched on that on the previous slide. You can do it manually with system switchover, or SysSwit, as most people type. And then there's in-service software upgrade initiated stateful switchover. And here's ISSU. Who uses ISSU? Raise your hands. Everybody get your hands up. There's a reason not to. We'll talk about it in a bit. So ISSU, in-service software upgrade, as its name implies, allows you to upgrade a Nexus switch that is in service, participating in the network. It's a pretty simple process. Copy the image to the switch, verify MD5. We all verify MD5, right? Nobody verifies MD5. And then we run one command, install all, give it a kickstart, path, and system path, hit enter. And it runs through a big process and tells you whether or not you want to do it, asks you whether or not you want to do it. You hit yes. And when you do that, it runs through all these processes that you see here. For you on the other side, here. It works. Where it's going to upgrade the supervisors, and it's going to upgrade connectivity management processors, and it's going to upgrade line cards one at a time. Note this is successive, so serially we're going to upgrade line cards. It says system-wide, you can't upgrade a virtual device context. So the entire system is going to get upgraded. You cannot do single supervisor in-service software upgrade. However, if you are in a VPC environment with a single supervisor on each side, you reload this chassis, there's going to be a swing of traffic. So there might be some service disruption when spanning tree converges or whatever on the other switch. So keep that in mind. While it's not in-service software upgrade, you can maintain some forwarding of traffic there. Here's an example of ISSU, which looks like release has been reformatted on this monitor. Sorry about that. We have 2 supervisors running here, one active, one standby. We run our install command. We're going to upgrade that standby supervisor first, initiate stateful switchover, and then the other supervisor, the previously active supervisor, is going to upgrade and reload. So now we have 2 supervisors running 628B. All of our line cards are still running the old version, so we upgrade those serially, one after the other. Best practice VPCs should be distributed because those line cards are going to reload. So keep that in mind. Upgrade paths are pretty important. So you can't ISSU from any version to any version. If you're running NXOS 4, which is where we added ISSU, you can't ISSU up to 6.2.12, for example. So this table here is taken from the release notes for NXOS. So these are real numbers here. You don't have to remember this. You can go check the release notes to verify what you want to do. But how you read this is, you see the current release. That means you want to go to, say, 6.2.12. You can get there from 6.2.8a, 8b, or 10. Now, what if you were running, excuse me, 5.2.7 and you wanted to go to 6.2.12? You can't get there directly. However, you can do a two-step ISSU. So it's going to take a little bit longer, but you'll have ISSU through the entire path. So you can go from 5.2.7 to 6.2.8a and then to 6.2.12. You'll notice in-service software downgrade is listed on here as well. Support is not as broad for in-service software downgrade. It is currently an option with these versions listed here. However, that's going to go away in service software downgrade. Also, you notice that incoming releases, the amount of versions that you can upgrade from and to for ISSU is going to be getting leaner. So as we're maturing this code, we're making decisions on where we can upgrade from and to. So expect to see these numbers get smaller. Like on the final large row there, you can see several versions of NXOS that you can upgrade to 6.2.8a. Expect to see those total number of versions come down in the future. Disruptive upgrade with installer. If, for example, you were going to do that two-step ISSU and you couldn't get a window for that many hours, this is an option as well, where you run your install command and it determines that it cannot do an in-service software upgrade. So it can do a disruptive upgrade. You just hit yes and it'll reload the chassis and start running the new code. Isolate. I'm going to say this word a lot. So you seen that video with Ballmer saying developers, 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 developers? I'm going to be doing that with isolate here at the end. I'm going to be all sweaty and running around the stage. Cold start upgrade. This is pretty simple as well. You simply copy the image over, check MD5, right? Set our boot statements, copy run start, show boot variables, and reload. This is not supported on the 5K. You have to use the installer. Isolate the node first, please. All right, let's do a quick scenario. You're at home sleeping, dreaming of waterfalls and unicorns, and you get a call that switches down in the data center. Get your bridge started, you call up TAC, and they say, you've encountered a defect, CSC XY12345. It's operationally impacting, or an OIB, as we call it in advanced services. Sorry to say, as an workaround, you got to upgrade. Have you heard this before? All right. So you sigh a little bit. You decide to get it fixed. Start up your bridge, you get advanced services on the phone. It's a plug for advanced services. I work in advanced services, by the way. Get your testers lined up and start the upgrade. And then all of a sudden TAC says, wait a minute, we got a SMU for that. And you're like, what? So what's a SMU? Who's familiar with ASR 9000 SMUs? 1, 2, 3, 4. All right, those are coming to NXOS. Round of applause. But what's a SMU? Maybe you'll clap after I tell you what a SMU is. So we're taking that concept from ASR 9000 where we can patch a running process and bringing it to NXOS. It's coming to NXOS 7.2 for the 5, 6, and 7K, which is at the end of the week, Arcady? End of the week. Another round of applause. 9000 has it there today. Fully support ISSU on the 7000. What are the benefits here? Well, you don't have to upgrade code in order to fix a bug, operationally impacting bug. We're taking that experience from the ASR 9000, we're bringing it to the 7K, and it allows us to better utilize software HA capabilities. So that process restart I was talking about earlier, this is using that. And we're looking to have a common cross-platform experience between 9, 7, 6, and 5K. Excuse me. Circle of life for a SMU. 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 All right, so we got our SMU repository here. This is not some unique piece of software that you got to buy from Cisco and get tech support and all that stuff. This is your TFTP server holding a bunch of SMUs. Install add will copy the thing to your thing. Install activate will apply the patch. So if it's patching OSPF, for example, install activate is going to apply the patch and then either reload or restart. We'll talk about SMU types in just a moment. Install commit says, I want to run this patch forever. Not necessarily forever, but we'll fix that word in just a minute. So it means that when I reload, I want to run this patch. You're committing it to the running system and for the foreseeable future. Install deactivate will remove the patch and start up the old binary for that process. Install commit, again, you got to tell the system that if I reload, I don't want to apply this patch. And install remove is going to delete the patch from your system. There's 5 show commands here on the screen. The first 4 will show you patches in various locations around this circle of life. Show install package info gives us one very important piece of information, and that is the type of the SMU. There's 2 different types of SMUs, restart and reload. Restart is going to restart the process using the high availability manager, which we talked about earlier, and reload is going to reload the entire chassis. For the restart SMU, note, if you're running OSPF in 2 different VDCs, both of those are going to restart. Reload SMU is going to ask you if you want to do it. Install commit is implicit. You don't have to commit after reloading. Some highlights here. You cannot patch to the next release. It's only for those operationally impacting bugs. It applies to all VDCs. ISSU will work. We're not going to release a patch where you can no longer ISSU. You don't have to apply all patches. If there's 7 available, you only need to fix 1 bug with 1 patch. Install the 1 patch. We have what are called roll-up SMUs. You ever say a word so many times it starts to sound weird? SMU. Some are single. We have roll-up SMUs like a service pack in the Windows world, but will operate much more stably. Tax supported, of course. They're synced to the standby supervisor. You don't have to worry about copying it to that other supervisor. If you replace a soup, the patch will be synchronized again. You will not see feature implementation or config modification with a SMU. It's only for OIBs. Any questions about that stuff? Yes, sir, in the back. The question was, if you install a SMU, does it impact your ability to upgrade? No. No, no, no. Whether that's cold start reboot or ISSU, it will be supported. 13 again. It will be supported. Yes, sir?
So when you install SMUs on your current version, you upgrade to the next version, does it just wipe out the SMUs with the old version? Or?
Yes. Okay. I'm sorry, the question was, if you, let me come back to that circle of life. If you install a SMU on the current version and then upgrade, does it wipe out that SMU? Yes. Provided, well, there is no provided. Yes. Your answer is yes. Now, you're going to want to make sure that the version you're upgrading to has the fix for that defect, of course. If it's not in there, look for a SMU for that version that you've upgraded to. Cool? Yes, sir? So the question was, what would happen to OSPF state if you're upgrading a SMU that impacts OSPF? The process we talked about at the beginning. So first, the HA manager is going to restart that process using the persistent storage service to repopulate state. That's nonstop routing, meaning we're not going to tell our neighbors that we're going to restart. Did I answer your question? Is that dangerous? Well, no. Or is that dangerous was the question. I wouldn't say it's necessarily dangerous in that we have provisions in there in case something occurs. We can do graceful restart where we send out those type 9 opaque LSAs and say, hey, we're coming back up. Our neighbor's going to helper mode and give us all the LS updates. So we have capabilities in there in case something occurs. We're not just going to, with nonstop routing, we're not just going to restart the process and not verify. We're still going to be talking to our neighbors. Adjacencies are going to be reestablished, but it's just we can participate much more quickly in the forwarding path, or the control plane rather. Any other questions? All right, let's move on to hardware. EPLDs. So this is kind of still a software thing. However, EPLDs give us the ability to upgrade firmware on an integrated circuit, on a line card or a supervisor, whatever the case may be. These are electronic, it's not EEPROM, electronic programmable logic device, kind of like FPGA, CPLD. It allows us to upgrade capability of an integrated circuit through a firmware update. They are extremely disruptive to traffic, and they take quite a while. It'll take about 30 minutes per I/O module. Here's what an EPLD upgrade looks like. In this example, we're doing just a single module EPLD upgrade. You can do all modules, of course, and they would be done successively. And it's typically not required when doing NXOS upgrade. If you try to do an update to NXOS, and it'll verify whether or not you need to upgrade EPLD. Also, you can check the release notes. And it's going to ask if you want to continue. In NXOS greater than or equal to 6.1, we have parallel EPLD upgrades. Round of applause for Nexus Business Unit on that one. So you don't need your 6 hour window any longer to do EPLD upgrades. But it's not going to do everything parallel. It's going to do supervisor, and then power supplies, fans, and then all line cards in parallel, or I/O modules in parallel. Line card hardware replacement. I wanted to bring this up because I never see it used. So even though online insertion and removal is supported on the Nexus 7000, we recommend running out of service module. This is graceful, quote unquote, to the system, saying that we're bringing this line card down, get ready, manipulate your forwarding decisions, reprogram your tables, because we're taking this module out. Mixed line card deployment between VPC peers is not supported. However, you're of course going to want to upgrade hardware in the future, so you can do it one after the other. This URL on the bottom of the screen, I know you can't copy this here, and tinyURL didn't want to cooperate. So if you hop on Google and search for Cisco Module Comparison Chart PDF, it'll bring you to this page right here. And it's a great resource that the 7000 business unit has put together that will show you which supervisors are compatible with which line cards. We're not going to be talking about it in this presentation, but there's going to be caveats with what kind of hardware upgrade you're doing, like F2 to F3. There's a particular process you got to follow to make that happen. So we're not going to cover it here, but take a look at this URL as well as other Cisco documentation, or stop by afterwards. We can answer those questions for you about which specific line cards work with other line cards. Line card removal, there's not much to worry about here other than did someone tighten the screws with a power drill? Push those ejector buttons, pull out on the levers. Note number 6 here, right hand under for all you left dominant arm folks. Ask a friend to help you, apparently. And did you wear your ESD strap? Chuckle. Everyone's laughing. MD5 and ESD. Everyone makes fun of those. Supervisor upgrades, whether it's dual supervisor or single supervisor, make sure you have the version of NXOS on the line, or I'm sorry, on the supervisor before you go and do that upgrade, just to save yourself some trouble. Out of service the thing on a dual supervisor system. Single supervisor, you're bringing it down, so just power it down and let's see what happens. If you're doing upgrades, single supervisor, make sure that you're going to have that type 2 inconsistency during the period of upgrade. So So plan for that outage. You can do a mixed supervisor upgrade in a VPC environment with dual soups. Just don't leave it like that. Upgrade them all during the same window once you go to production. Chassis hardware upgrade, organize a work party, get 10 friends, forklift, and pull that thing out after you remove all the screws. In all seriousness, though, be careful with these things. I've seen a data center tech taken off one night, throwing out his back, so be careful with them. Bring the switch into GIR mode. What is GIR mode? I'll tell you later. It's a pretty neat feature that we're going to be talking about. Fabric modules is not much you have to worry about here other than don't oversubscribe to Fabric. However, if you've taken our advice and gone into isolation mode on the switch, then Fabric shouldn't be utilized very much, right? But you can check hardware utilization, Fabric utilization with this command here before replacing that Fabric module. Power supplies, be mindful of power budget. We always recommend running in redundant mode. You don't want to pull out a power supply and then realize all of a sudden line cards start powering down because you ran out of power. Show environment power will show you total capacity based on mode, as well as how much you're actually using, so you can make that smart decision about whether or not to pull out that power supply. Any questions on hardware? Pretty easy stuff. Yes, sir? Yes, sir. Yeah, I probably should have mentioned that. So the question was, when you push those buttons, doesn't it do that? Yeah. When you push those ejector buttons, it informs the system. So there is some smarts going on in there, but we're still going to recommend it. Any other questions? All right. Oh, I'm sorry, in the back. I'm sorry, I can't hear you. Arvin, could you relay? I can't hear it at all.
So when you remove the line card, it removes the configurations?
No, the configurations will be retained, provided you're replacing it with a similar line card.
So the question is, when you remove a line card based on experience, it, sir, for you, it has removed the configuration and also the port allocations details.
Oh, that's not expected.
It is like to like or like to unlike line card change. Are you replacing with the same line card? We can discuss this. So the question is, and if I rephrase the question, if you have certain cases when we remove the line card, right, and if it is like to like or like to unlike, you might, based on experience, what's been mentioned is the configs have gone, the port allocations have gone, and that's something, the risk factor. And one of the things that we were going to cover is node isolation. When we start looking into node isolation and automate the node isolation using GIR, this will help you take care of these type of corner cases unexpected. Because when you get into a change window, we're expecting something unexpected to happen. So 2 times. And we can take that more in detail after the session and discuss about it, what exactly is the case. But that's unexpected thing that is being talked that we normally see during change windows, as we all have this experience.
This gentleman has feedback. Yeah, you'd lose it. Yeah. Yeah, good point. So what this gentleman just said, that you pull that line card out, copy, run, start, that config is missing once the line card is out of the system. Once you put it back in, that config should exist again, save config, and move forward. That might be what this gentleman was experiencing. But we're happy to talk to you afterwards. We have those resources here who can try to figure out what happened. Node isolation. We're going to talk about protocols. Let's talk about an example. So we have a very simple network here, WAN router, core, aggregation. It's a new word. Aggregation or distribution, whichever word you prefer. IBGP to the core, OSPF to that distribution switch down there. Currently, we are taking all of our WAN routes, sending them to the core with IBGP, and redistributing those into OSPF. And in this example, we have no reason to do that. I can think of one really good reason to do that, but work with me. So our plan is to create a static default to null 0, originate that default into OSPF, and then as traffic comes up to us, we'll make our forwarding decisions based on those IBGP learned prefixes. Now, because it's a static to null 0, that's never going to go away. That route can never go down. So we're always going to be originating that default. OSPF converges much more quickly than BGP most of the time. So we run into a situation where traffic would be black holed. Traffic's coming up to us. And we don't show another path in the network or in the picture here, but there is one. There's always one, right? So what can we do about that? We can manipulate our routing protocols to get traffic to route around us, gracefully shut down our protocols, gracefully, quote unquote. So we have to make a distinction here between gracefully. We've been talking about graceful restart and nonstop forwarding. This is graceful to the system. So we're going to use the word graceful a lot. And whether it's graceful to the system, like out of service module, or graceful to our neighbors is a distinction we need to make. OSPF, max metric router LSA. Who uses this? That guy does. This gentleman over here does. It is recommended. So what we're talking about with isolation is we're going into maintenance window and we want to get traffic to route around us. But what would be really cool is if we could maintain those adjacencies so that when we want to come back into participating in the network, we don't have to reestablish those adjacencies. We already have our ribs populated. Let's just manipulate our metrics. So that's what we're trying to accomplish here with all these different protocols. Max metric router LSA was an afterthought, meaning it came in its subsequent RFC to OSPF, where we can tell our neighbors using LS Infinity that we're going away. Don't send me traffic. It's basically like the worst metric possible. Two other options that apply to all of the other protocols we're going to be talking about, whether we shut down the entire OSPF process or shut it down on an interface. Now, there is a reason in a maintenance window to just shut down it on an interface. For example, if you're just replacing this line card, but you need traffic to continue forwarding this way and maybe this way, that would be a reason to shut it down on an actual interface versus isolating the entire OSPF area. ISIS, who uses ISIS in the data center? Nobody. Who uses Fabric Path? Keep your hands up. Who uses ISIS in the data center? I understand that. You don't actually see the ISIS. So this was part of the original standard definition for ISIS, a set overload bit. This is where we tell our neighbors we're too busy to process traffic, so don't route anything to me. This is the configuration option, and I probably should have mentioned that previously. Max metric router LSA, this is the configuration option to tell our OSPF neighbors not to route traffic to us. ISIS has the set overload bit option. And you'll notice the extra configuration parameters we have here, whether it's on startup for a number of seconds, wait for BGP to be up. So this directly addresses the scenario we went through at the beginning. This is recommended. All of the recommended options maintain the control plane and the adjacencies. We don't have any type of message in the IGRP to tell our neighbors not to send us traffic other than manipulating K values. Here in this scenario, we go onto an interface, manipulate delay so that traffic goes elsewhere. And again, we can shut down. For BGP, there's a couple different options, of course, whether it's external or internal BGP. You can prepend AS path to keep traffic from coming to you from your external neighbors. Modify local preference to keep traffic from coming to you from your internal neighbors. This is an example of AS path prepending. There is also router BGP shutdown. There is a new RFC, relatively new, for graceful shutdown of BGP, which will tell our neighbors through the gshut community that we're shutting down. And you can actually tell your neighbor for how long, or like I'm going down in 10 minutes, which allows those neighbors to know and notify their neighbors, et cetera. This is not in NXOS yet. It is in iOS XE, if you're curious to take a look. However, even though we're not doing gshut, we are going to send that notification as well as terminate TCP properly. So it is quote unquote graceful to our neighbors. And then there's always this option, system interface shutdown. If you shut down an interface, the traffic's not going to come to you. So this will shut down all the interfaces on the system. And this one is actually used quite a bit in a couple slides from now. VPC shutdown feature. So prior to version 6, or I'm sorry, less than or equal to 6, there was no way to easily shut down a VPC or isolate a switch from the VPC domain. You had to go in there and follow the process manually, which is, peer link, peer keep alive link, VPCs, members, and then you're isolated, right? In version 7.2, we have VPC shutdown, where VPC domain 10 shut down. When you do that, it's going to run through that manual process, for you. And when you come out, it will reverse the process. This is available in NXOS 7.2, end of the week. Cross your fingers. All right, any questions on what we've basically gone through is manual isolation. Now we're going to talk about new feature, bee's knees. It's really freaking cool. So before I move on, any questions? No? All right. Let's take this 7000 series switch here. We're running OSPF and VPC. We want to isolate it. That's our recommendation, isolate switches for maintenance. So we're going to do max metric router LSA. We're going to shut down VPC, provided we're running code that doesn't exist for your consumption yet. Scripting this takes time. The person who implements your script, or rather, you're not always the person implementing your script. So it would be great if there was some way to automate this. Another scenario, we have our VPC pair here, forwarding traffic via switch 1 on the left, switch A. Change window begins at 6:03 because John joined late, like he always does. One single command, system mode maintenance. It's the easy button of isolation. Generate a pre-change system snapshot. So look at the diagram on the right. All the interfaces are down. Traffic is forwarding via, or may not be down. We're just not forwarding traffic via those interfaces. Change window is over 12 hours later, exactly 12 hours later, 6:03 a.m. No system mode maintenance restores us back to the previous state. So it's pretty cool, right? Oh, there's a bunch of questions. Ma'am, you said, is it available now? Friday. This coming Friday. Yes, sir? Well, hold on. Before I start answering all the questions, we have about 10 or 15 more slides on GIR, so I'm not like leaving the topic. So I might answer your question, but what do you got?
The control plane is up.
I'm sorry, one more time. I'm going to get to that. Another question? Any other questions before I move? All right. There's going to be one slide, sir, that in big words says protocols still matter. And that's going to answer the question. All right, so NXOS 7.2, end of the week. Initial support for ISIS, OSPA, FIGERP, and BIGPA, as well as interfaces. We used to do that, back when I was, immature. I've grown up. Let me touch on Camden here. So Camden is our internal name for Nexus 9000, for the upcoming N9K release. We're not supposed to mention names like this, but they don't know what the number is yet. So we're telling you Camden. I've been informally informed that it's 703, but that can change, so don't hold me to that. If this is being recorded, bleep that out for me. 2 different configuration profile types. There's a maintenance mode profile and a normal mode profile. You go into GIR with the maintenance mode profile, and you come out of it with the normal mode profile. For both of these profiles, there are automatic profiles and there are manual profiles. Default is an automatic profile. So when you do system mode maintenance, what this does is it parses the configuration, it looks at what's configured, and then generates a script to isolate the device. Okay? Our projected use of this is for maintenance windows of automatic profiles. Manual profiles allows us to define what we want to occur going into and out of GIR mode. So we can actually go into configuration mode, define, I want you to execute these commands in succession when I type system mode maintenance. So you can do these manually. We expect these to be used for those folks that are a little bit more hands-on with the scripting in their maintenance windows or for troubleshooting. So, you have a switch up and running and it experienced some sort of impact, some sort of issue. First step, unfortunately, is to reboot the switch usually, and we don't want you to do that because we want you to get TAC on there to see the switch in that degraded state so they can tell you what's wrong. It's really hard to determine root cause once you reload that thing. So, don't, please. Consider isolating the device. Route the traffic around. You'll experience that sort of degraded environment, but provided you can sustain it, isolate the switch, get TAC on the phone so they can see those counters, they can see the logs, they can see whatever they need to see to determine what happened. Here's an example of going into maintenance mode with an automatic profile. So you see that it is parsing the configuration, determining what it's going to do, and once you hit yes, it'll do it. So I bolded 2 things here. OSPF was found, so it's going to shut it down. As well, interfaces are going to be shut down. This is a default behavior, system interface shutdown. But it's going to shut down those protocols first, so that if there is some method of notifying neighbors that we're going down, it will be used. Show system mode will show you which mode you're in. Here's an example of a custom profile on the Nexus 5000. You do config T, config profile maintenance mode type admin. Here's all the commands I want you to execute. When I go into maintenance mode, when I come out, here's what I want you to execute. So you see, whereas default we're going to shut down a routing protocol, with manual we can manipulate forwarding, whether it's max metric router LSA or this set overload bit. By default, that really gets louder when by default, it's going to do automatic profiles. If you have a manual configuration profile defined and you go into it with automatic, it's going to overwrite what you have in configuration. So be careful. Also, you cannot go into with manual and come out with automatic and vice versa. So if you go in with automatic, you got to come out with automatic. There is an option. If you want to do a manual profile like this, you always have to say don't generate profile when you go into maintenance mode. Protocols still matter. This is not a magic bullet. If a protocol does not have a way to tell our neighbors that we're going down, expect them to operate as they would if they went down without you telling them to. So spanning tree, once you do that system interface shutdown, expect the spanning tree convergence to occur. IGMP, PIM, LACP, expect them to have some sort of convergence event. We have options for some protocols, for other protocols we don't. System interface shutdown is going to make it happen no matter what. So this is always an option if you need to isolate these particular protocols. So going back to the VPC question the gentleman asked, is there some sort of, caveat or way that GIR can handle VPC inconsistencies? And the answer is no. Because all you're doing is you're bringing a switch down or you're bringing it back up once you go into and out of GIR. So expect whatever were to occur if you weren't using GIR to occur if you are using GIR. Get it? Sir, did I answer your question? VXLAN, Ethernet, VPN. Anybody using this yet? Anybody playing with it? Okay. So what can we do to isolate? Say we're using the manual profile here because we want to do max metric or prepend AS path. With the Nexus 7000, you can go in there and very specifically say router OSPF 10, max metric router LSA, router BGP 10, prepend last AS, route map and all that stuff. It's only going to let you configure within a configuration profile what is available and supported. So don't expect to go in to set the configuration profile and be able to do something that is not supported. Once we prepend AS going to our eBGP neighbor and modify OSPF metrics going to our VTEPs, then the device is out of the forwarding path. However, our adjacencies are still established. So we still know what the network looks like. It's just nobody is sending us traffic, which is very important when you want to come back into participating in the network. Another example, layer 2 and layer 3 graceful insertion and removal, BGP and OSPF from our aggregation layer here, and then layer 2 going down. System mode maintenance, don't generate profile. We can manipulate AS path and max metric up in that direction and the layer 3 direction. And for layer 2, we can do system interface shutdown and VPC shutdown. Once we do that, of course, with system interface shutdown, the device is going to be very isolated. But by doing the routing protocols first, it allows traffic to reroute around us before we shut down those interfaces. All right, quick call out to Junmai Zhang with the Nexus 7000 business unit. We worked with her quite a bit to develop these next 3 slides. She wrote a white paper on this, which is available on Cisco.com, where she specifically talks about graceful insertion and removal on the 5K with FEX. Because there's some things you got to keep in mind. And the big thing you got to think in mind is that it won't by default exclude FEX fabric interfaces. Why would we want to do that? Let's look at a scenario where we're upgrading software on a 5K. If we go into it with an automatic mode profile, interfaces are going to go down, including FEX fabric interfaces. Once those go down, FEX is unknown to the 5K. So once we come out of GIR mode, the FEX is going to come up and online. It's going to notice that version mismatch and have to upgrade itself. And there's a short period of time that could have been avoided had we excluded FEX fabric. So we recommend not doing an automatic profile in these scenarios. Do a manual profile. And again, this is only needed if you're actually shutting down interfaces. If you're doing a manual profile and you're not going to shut down interfaces, then don't worry about it. If you're just doing some other configuration for maintenance. Got a bit of a scratch in my throat. Sorry. Here's another example, and it is the. Oh, I'm sorry. What's up, my friend?
Talking specifically about 5Ks and FEXs. I'm assuming the same feature set and logic is
Yes.
7Ks using FEXs?
Yeah, the question was same experience with 7Ks and FEXs. Yes. Yes. Great question. Have a T-shirt. We don't have any T-shirts. Another example here, this is where we have VPC pair talking to FEXs. It's the same thing, exclude FEX fabric interfaces because FEX is unknown, we experienced that outage, and we got to wait for it to be upgraded. This next scenario, though, where we have our Fexes dual attached, which is coming in 7.2 at the end of this week. Round of applause. What happens in this scenario? Our Fex is still up because of that dual attachment. We don't have a good solution for this in graceful insertion and removal. So we recommend doing in-service software upgrade, because when that 5K on the left goes into GIR mode, that Fex is not going to go down. It still has an active member in that virtual port channel going to the switch on the right. So once we come back up and out of GIR mode on the switch on the top left, nothing's going to happen, and we're going to run into a problem talking to that Fex. So use ISSU in this scenario, and ISSU is going to handle the situation appropriately. So you can do them one after the other. You don't have to install all on both 5Ks and hit enter at the exact same time. But we can handle this with ISSU. Nexus 9K, they decided to be a little different. However, this is coming to 7K as well. So what 9K did was they added this isolate feature. So in the 7K we have shutdown, which is going to shut down the protocol, and that would be by automatic. 9K added an isolate keyword, which is pretty cool. And what they're doing is all the things we talked about in manual isolation, they are implementing with this single keyword isolate. And this allows us to maintain those adjacencies. So OSPF will stay up. We'll still have those neighbor relationships. We're just telling our neighbors, don't send traffic to me. Similar to BGP. Multicast is going to follow the unicast forwarding table for reverse path forwarding, so you don't have to worry about anything there. Let's look at what actually happens. With BGP, it would be pretty hard to parse a configuration, determine the autonomous system, and figure out what to prepend where to which neighbor, or do I do local preference? So what we do, someone had a light bulb go off, and they're like, what if we just tell people not to, we don't know how to get to anything. So we just stop advertising everything. We don't pass, there's no transit. We don't originate anything. We just stop advertising. We maintain adjacencies. We still get our BGP updates from our neighbors. We still put those into our BGP rib. And we'll populate our FIB based on that information. But traffic's not going to come to us, so we don't have to make a forwarding decision, so no worries. EIGRP is going to do max K values for all metrics. OSPF will implement max metric router LSA, and this is all in the background. It's not like you have to, what was I going to say? It's not like you have to type max metric router LSA. You just type isolate. ISIS is going to do the overload bit. And for all you RIP in the data center folks, there's an isolate there too. Anybody? Are you willing to admit it? Yes, sir.
You say that you isolate the node so that you do not receive traffic, but you can generate traffic.
The question was, you isolate the node so you don't receive traffic, but you can generate traffic. Like a ping? If I receive a packet and I'm in this situation where I've run isolate on all my power, I'm going to forward it because I still have my adjacencies there. I'm still learning routing information. I'm just telling my neighbors that I'm a really bad way to get there. So by manipulating OSPF to do that LS infinity, that tells my neighbors that, yeah, he's still my neighbor, but I don't want to go there. That's bad lands. Oh, yeah. Again, I'm sorry, the question was ISIS overload bit is still going to allow the router to participate? Yes, all of these will allow the device to participate in forwarding. It's just telling our neighbors that we're a bad way to go. I don't feel like I'm answering your question appropriately. Let's get together afterwards and see what we can get worked out.
Just to add on to Nick's comment and explanation, when you get into the real planning, we don't go with one feature isolation. We go with multiple features isolation. So when you do what Nick is talking about, the routing protocol isolation, but once we get into the end, we go through a sequence of isolations because your system is not only routing protocol, you're also looking at your interface isolation, VPC isolation. So you get the complete data plane isolation in this particular case.
Okay, let's move on to graceful insertion, which is the opposite of removal. No isolate. It's as easy as that. Now, what? Now, what this will do is it will reverse the stuff that we did previously. But one thing is really interesting here in that the 9K is going to program hardware before manipulating those metrics. So we program the hardware, and then we tell our neighbors that they can start sending us traffic. So when that first packet comes in, the hardware already knows where to send it. Pretty cool innovation here. It's one of those, why didn't I think of that sort of things? Snapshots. I touched on this at the beginning of this section. Let me tell you what it actually is now. So a snapshot is taken before or as you go into GIR mode, and it's taken as you come out. Those snapshots are compared automatically for you. And a snapshot, snapshot is basically gathering show output so you can compare them afterwards. Here's a manual snapshot creation. Snapshot create, give it a name and a description, and it will parse the configuration to look for things that are enabled and run a show command for that stuff, like show IP, OSPF, VRF, For things that are not enabled, it's not going to execute the command. And then there's a compare command, so you can, before maintenance and after maintenance. Before maintenance and after maintenance are the names of the snapshots that are created automatically for you. And it'll do a diff between them. So in this example, I grabbed the BGP output. We can see that last flap before maintenance was at 9:05 and 12 seconds p.m. Kind of confusing there. And then post maintenance, last flap was at 9:25:47. So that gives you an idea of how to read that stuff. Final slide for me before my standing ovation. Feature support. So in the 5K, 6K, we'll see it in 7.1 GIR. 7.2 in the Nexus 7000 end of this week. Look for it. And for that Camden release, 7.03, hopefully, look for that the last 6 months of this year, like Comcast. Be there from 8 to 4. Nexus 3000, no support. They are considering it, though. Any questions for me before I hand it back over to Arvind to talk about maintenance windows? And I'm going to give you a quick summary. No? All right, so I talked about software. That being, do ISSU, it's recommended. Talked about some best practices for software, verifying MD5, of course. Hardware maintenance, we talked about things to think about. The big thing over all 4 of these sections was isolate. We want you to get those devices out of the forwarding path before you start messing with them so that you can avoid unplanned impact. GIR will allow you to do that quickly and easily, streamline those change windows for you. So take a look at that. Consider integrating it into your processes and your maintenance windows to make things a little bit simpler and maybe reduce calls to TAC. Any questions? Okay.
Thank you, Nick.
I'm out of here.
All right. Thank you, Nick. So Nick went through the bells and whistles and the features that's available right now and the future roadmap of features available in the next coming releases within the Nexus. And what I'm going to go through is change window best practices. Best practices is a methodology. It has to be customized to your environment, right? And each of you have a best practice for operational availability that you guys follow in your environment. So one of the key things in change windows is very high-level golden rules, and this is not technology, guys. This is how you manage your expectations of your key stakeholders. Have a review board. Make sure there's a good peer review and a solid process. Schedule a change window when it's least impacting. In peak time, if you have to do a change window, let everybody know the risks. The execs, everybody know the risk, that this is a peak time and I'm doing a change window based on a business critical issue. Software staging. Staging is great. Staging is great, and if you can stage the software in your lab environment or type of proof of concept environment, that is great. If not, if you have to stage it in the live environment, sometimes it has to be that way. Verify out-of-band access. A lot of times we get into a change window, we get into this, and when we start, especially, Nick talked about isolate, isolate, and isolate. This feature isolation, right? When we isolate a node, we start looking into, we might cut our own feet by not having access to the device. So out-of-band access has to be verified. Test before and test after. And testing might have different values to it. And we'll go through that in the next few slides. These are the golden rules. Working in advanced services, we plan change windows for our customers. We have a process and methodology that we align with what our customers have to use. The first planning, change window pre-planning stage is implement the backout. So a gentleman out there, they asked that question that once the line card was put in, reseated, the configs didn't come up. Sometimes, stuff happens. So what is a blackout? What is a backout for this particular issue? Plan it up. Test and plan the testing. What type of things that you need to include? Do you need to include application folks, all the application folks, or just the tier 1 application folks? Go through a peer review process. And once you go through the peer review process, if there's a feedback, circle back to the same process, then the bulb out in the slide before the business owners is nothing but documentation. Documentation is important for the method of procedure. Go through the business owner's review, and that is key because the stakeholders need to understand the impact and the risks that's going to take place in the whole change window process. Go through the approval process so that the business owners also have a stake in it. Then start planning with the application, the nuts and bolts, right? The technical planning, how to do it, who are the guys to be doing it, stage it, out-of-band access, and start the implementation of change window. Test the plan, and if it's successful, notify and document. If it is not successful, back out. This is a process that's a 5,000-foot overview process that we normally use to customize the steps for our clients' needs. Now let's go back to how we started. Use case, traditional environment. If you want to isolate a core, the first step I would do, and all of us are in 6.x code. We are not in 7.2.2 to use it right now. But to isolate a core, the first thing you need to do is a layer 3 protocol isolation. You don't have GIR right now in the 6X, the current code you're running. You would think about different ways that Nick went through, OSPF, ISIS, BGP isolation. Think about that, first isolate that. That would be the first thing I would isolate in my change window. The next thing that you need to isolate is, how do I isolate the VPC domain? Look into the features like VPC shut. If it's available, use it. If not, you need to do VPC isolation based on the steps for the VPC shut. And interface isolation is in the end to completely isolate the device. Now, in 7.2.2 code, you can achieve all these steps using GIR. Automatically configured GIR could be, or we could have prescriptively, we could manage all these things using GIR. Now, using GIR, what really happens is it reduces, every time I go through these different steps, I need to touch multiple VDCs. I need to go to each of the interfaces and type those commands in, and this does take time. If I have a cool way of one command and everything else goes into the shut, isolate state. That makes my in-flight packet loss reduce. Access isolation, when you're looking at access, in this particular is double-sided VPC, isolate the layer 2, VPC. Then think about if you have FEX connected to the access. Nick went through a couple of slides. There's a white paper also available on this. Different things, whether you want to isolate the FEX or not isolate the FEX. And if the change window requires software, leverage ISSUs or SMU based on the feasibility. And when I summarize this, I'm going to go through certain use cases where I would use both of them together. The next best practice is layer 3 isolation for a layer 3 environment for spine and leaf. You know, your relationship between your spine and your leaf is based on a layer 3 protocol. And most of the cases where we see this environment is using BGP. Simple process, go for graceful layer 3 isolation and do the interface isolation. And if these two things are achieved, that means the spine is, or the core is isolated. Using GIR, the same 1 and 2 steps could be achieved prescriptively. The next is access isolation. Again, it's layer 3, so the whole system has layer 3, so layer 3 isolation is a must. Layer 2 isolation, you do the isolation of VPC, and then you start thinking whether it's connected with the FEX or not. The same comment for GIR and ISSUs and SMU is true for this particular system also. Fabric path. For fabric path, you do the isolation for the control plane. ISIS isolation could be done on ISIS overload bit, but you need to go into the fabric path mode to do it, not onto router ISIS to do it, because in this case it's hidden, it is within the fabric path mode. You can use a GIR manual script, a custom script, to achieve it once you move to 7.2 code. Leaf isolation, we can do it using VPC Plus, because in VPC Plus, what happens is the two fabric path switches under a VPC domain has the same switch ID. So just use VPC Plus isolation techniques, and you can achieve isolation out here. VXLAN environment. So in VXLAN environments, especially with EVPN, we could have eBGP or iBGP. And you also have to think about how you plan the underlay. There's several breakout sessions on VXLAN. Please go for these breakout sessions. But when you start looking at underlay and overlay isolation, it's simple from an operations point of view. I don't care if it's underlay or overlay. I need layer 3 routing protocol isolation. I look at the configs, it's BGP, I'm using OSPF as an underlay. I need to take care of these two protocols. First thing, I would take care of these two things. The next one, I start looking at interface isolation. As the gentleman clearly mentioned, if I do isolate for my routing protocol, everything doesn't get isolated. You still have some traffic coming in. So you have to look at the next step of isolation, where you start looking at interface isolation out here. And the leaf isolation, you start looking the same thing, because your control plane is built even from the leaf. So the routing protocol system is applicable to the leaf also out here. So you do layer 3 isolation, whether it's eBGP or iBGP, you can decide based on the design and the configuration. Then do the layer 2 isolation, and VPC is very much prevalent even in a VXLAN design, like in the case of the fabric path. Verify if you need to isolate FEX. So all the nuts and bolts which you went through, FEX isolation, VPC isolation, routing protocol isolation, is applicable to any environment you take, whether it's fabric path or VXLAN. Use GIR once you move to 7.2 code. GIR, you can leverage GIR. So one is you can have an automatic generated profile that the switch will go and review what you have configured, and it will make changes to it and isolate the device. The other way you could do is you can make a custom script. So every time, now normally working with multiple customers, what I have seen is every time there's a new architecture or design that the design team is looking into, the operation leads also are part of the design process to understand how simple is it for me to operate this particular design. When you're looking into this, moving forward, you need to also, in the design guide itself, when you're working with it, have process and steps, how do I isolate? And you can have that as a part of your config. So if you want a planned or unplanned event, when you see in the operations just wants to isolate a device, you just have to use that GIR mode command, a custom script, if that's applicable to your environment. So have that in the initial process itself. Guys, how do I isolate this particular switch in this particular design fabric? In summary, we have multiple options out here. And some of these options could be a combination of one or two options for a specific outcome. You might go into in fact, I see one of my customers out here. We went into 18 hours change window. 18 hours change window, 6.x code prior to 6.x code. We had OTV, DCI, and we also had VPC. So one of the first things, and the key thing is, one of the first things that we all planned collective is, let's deploy the best practices first before we get into the change window for a code upgrade. It took us 18 hours, and we didn't have all these cool features. I think the maximum ping drops we got was 4 ping drops across. So it is the planning that is important. How do we isolate? I don't have these cool features in my customer's environment right now, but if I plan things of isolation, I can achieve a lot of things in the whole environment and make it more seamless from an application process. So the options that Nick went through out here is ISSU. There's all a list of options that Nick went through out here. There's a bit of echo. Is it okay? Are you fine? Okay. So these options are listed out here. Now, the tick mark is yellow and green. The yellow tick mark really means that you need to do some type of planning before the change window, or there is some type of condition that needs to be taken care of before the change window. ISSU, the reason is tick yellow. The reason is the ISSU upgrade possible? You have to plan that. If it's not possible, that's a condition. GIR. You mix GIR with a couple of other things. Your GIR means you isolate it, and then you can decide whether you want to go for a cold boot or disruptive installer. Anytime there's a GIR, when you're doing isolation, you're going to have an in-flight packet loss. But that could be optimized. For example, if you look at VPC isolation, it is sub-milliseconds, and it's been tested. So you have that feature enabled, go for GIR, and you will get a more optimal loss for your in-flight packet that makes it more seamless and graceful for your applications in your data center environment.
Hey, Arvin. Arvin,
Oh.
over here.
All right, you're out here.
Yeah, sorry to interrupt you.
Go ahead.
I know you're not expecting it. I wanted to touch on something I forgot to mention in my section.
Go ahead.
And that was for cold boot versus disruptive. There's one key difference there that's very important that I forgot to say. And that is, when you do the disruptive installation, it's going to notify you about configuration differences that might occur through that upgrade. So if a command is not supported in the version you're upgrading to, it's going to let you know. Cold boot is, you're going to reload to the new version. You might see some errors. Some configuration might not be there. So that's a big distinction between the two. So keep that in mind. Sorry for the interruption.
Perfect. So GIR all by itself does not provide us this particular outcome for pre-cert or bug fix. So that's not an option. For hardware, if you have to do a hardware change, The one method that we could use for isolation is GIR. GIR to one system is green, but if you do GIR to the complete system, if you're changing all the hardware in your particular fabric, your data center fabric, you are going to take some type of risk. The next one is when you add new features. Yes, ISSU patches are available. It is applicable. You can do ISSU. You don't have to think because the control plane is getting changed, whether your data plane is still forwarding. Your GIR with cold and GIR with disruptive is something that you can think about, because once you do GIR, you have much more control about your isolated environment. Your planning, especially as anything that's not been documented that you see is being covered using GIR, because you isolate it, and then you can use cold and disruptive installer. Risk adverse. ISSU, doing ISSU, you avoid risk because it is very proven that only the control plane is getting changed, only the data plane is still solid. For GIR cold boot and GIR disruptive installer, for this you need to do some type of pre-planning before you start it, and that's one of the reasons it is yellow in color. The smooth restart, and as Nick says, smooth, right? Smooth restart process, leverage it. If it is applicable to your environment, use it. It's a great thing. It's there in ASR 9 case. I've used it building MPLS environments with customers. Use this process wherever it's applicable, is risk adverse. GIR with smooth reload is another thing that you could use. And again, you need to do a bit of planning to verify whether you go with automated GIR or a customized GIR method. And GIR alone is risk adverse.
Not risk adverse. Not risk adverse.
Okay. So in summary, you guys are going to be going through multiple presentations and breakout sessions in CiscoLive. One of the things that after this session, we both have done a good job if you understand the data center best practices that is pertinent for operations, right? And how does it really impact us during unplanned and planned changes? Follow the documentation process, the management processes. Document everything. Make sure, not only from a network perspective, but application and also the key stakeholders, the execs, understand the risk, because nowadays, if you touch a data center, everybody's looking at you with a spot eye. So make sure everybody knows the risk, what you guys are taking, and the planning that you have put. That has to be well documented and communicated to all levels. We talked about cool features, smooth, GIR. Use GIR process in all your maintenance windows. VPC isolate feature that's available in 722 code. Leverage that. And also in your architecture and design, when you start working on a new design, GIR, those type of how do I isolate a device should be a part of a design from an operations point of view. You need to ask your design guys, all right, this is a great fabric part design. What are the steps for you to isolate this particular node, spine or leaf? Keep it very high level. Have those scripts generated, tested, and also deployed if you want, because suddenly in the middle of night, as what Nick mentioned, when you get a call, you want to isolate a device, boom, you can isolate a device. Again, change windows, maintenance windows, or clearance windows, that's not a science, guys. It's an art. Every change window that I have been is different, and all you have taken care has been different. You have to be innovative. Only one thing is now, from Cisco's perspective, we are bringing out features that makes our life a much more simpler during the 16 or 18 hours change window that we have to go through. Last not but least, evaluation. Cisco takes the evaluation very seriously. So we appreciate your generosity in your evaluation for Nick and myself. But more than the scores, what we are also important, we want a feedback is the features. Because this is a cool media for us to provide some type of input to the business units. Do you like this feature? What you would like to see future in the roadmap? There are more things that's coming out maybe next year when we guys meet, we will be able to talk about those cooler things next year. But the thing is, give your feedback, give your input, and that's the key thing about the evaluation. With that, we are open for questions. Thank you, guys.
Hey,